Hello students, I am Mr. Ashish Nikhade. I am going to start the series of applied mechanics lecture. This one is the first lecture regarding the same subject, that is applied mechanics. This subject is included in the second semester of engineering field, that is mechanics. So the first concept is, or first topic is, that is fundamental of mechanics. What exactly included in the mechanics subject? So first of all, we must know about the definition of mechanics. So first concept is mechanics definition. So it is a branch of science. Mechanics is nothing but the branch of science which deals with the study of forces acting on a body when body is at rest or is in motion. That means in the mechanics we have to study the effect of forces acting on a body, but when that body is at rest or is in motion. So this is the simple definition of mechanics. Then next is classification of mechanics. Mechanics is basically classified into two terms, that is statics and dynamics. We already studied the definition of mechanics where we said that mechanics is nothing but the study of forces acting on a body when body is at rest or is in motion. So on the basis of this rest and motion, this mechanics can be classified into two terms, that is statics and dynamics. The term statics is related with the rest condition and dynamics is the term related with the motion condition. So what do you mean by statics now? Now see, this statics now is a branch of mechanics which deals with the study of forces acting on a body when body is at rest. Now here only the word that is rest, because statics is the term which is related with the rest condition. Then what is dynamics? Now it is a branch of again mechanics. So we can define dynamics. It is a branch of mechanics which deals with the study of forces acting on a body when body is in motion. So whenever there is a motion, then dynamics. Whenever there is a rest, then statics. Now then there are two types of motion. The motion may be due to the external force or due to the internal forces, own forces, or inertia forces. Is it right? Due to the own inertia. So on the basis of that, dynamics can be classified into two terms, that is kinetics and kinematics. Both the term related with the motion, but that motion is due to the different type of forces. How it is? Let's see. So kinetics is, it is a branch of now dynamics. So we can define it. It is a branch of dynamics which deals with the study of forces acting on a body when body is in motion, but motion is due to external forces. That means external forces causes the motion in kinetics. Now what is kinematics? It is a branch of dynamics which deals with the study of forces acting on a body when body is in motion, but this motion is without considering the external forces. That means the external forces will not cause or the motion in the kinematics. Okay, so see, you can see that is in each and every term the word in the definition are same, only difference in the last word. Statics, there we use only rest. Dynamics, motion. Then motion is again into two types, due to external forces, and in kinematics that is due to the own forces, internal forces. So this is the simple classification of mechanics. Okay. Now next is nothing but the mass and weight. So see, we are going to discuss these two terms in the form of difference. So what is mass? What is weight? So see, I classified these two terms on the basis of three parameters. You can see there. First one is the definition, second is the notation, and third one is the relation. If the question will be asked in the examination, define mass and weight, you can write definition. If the question asks that is differentiate mass and weight, then you can differentiate these two terms on the basis of three parameters. So first is definition. So what is the definition of mass? It is very simple. The quantity of matter contained in a body is known as mass. Then what is weight? That is the force with which body is attracted toward the center of earth is known as weight. Very simple. Because due to our own weight, we are attracted toward the center of earth. That's why only we can stand easily on the surface. So mass is the quantity of matter contained in a body is known as mass. What is weight? The force with which body is attracted toward the center of earth. Next is the notation. Very simple. Mass is denoted by m, small m, and the weight is denoted by w, capital W. Then the relation. You know the relation, that is W is equal to mg. So you can see there in weight, that is W is equal to m into g, that is weight is equal to mass into acceleration due to gravity. Now what is the relation between mass and weight now? So m is equal to W upon g. So this is about mass and weight. Now next is scalar quantity and vector quantity. Again, we are differentiating these two terms on the basis of two parameters, that is definition and example. Now first is, what is scalar quantity? So see, it is a physical quantity having only magnitude but no direction. That means the quantity which has only magnitude, no direction at all, is known as scalar quantity. Now what do you mean by vector quantity? It is a physical quantity but having magnitude as well as direction. That means the difference is very simple. That is the quantity which has only magnitude, that means value, but no direction, it is nothing but a scalar quantity. The quantity having magnitude as well as direction is nothing but the vector quantity. Now what are the example of scalar quantity? The quantity which has only magnitude, value, not direction. The very simple example, that is mass. Mass doesn't require any direction. Time, then speed, area, volume, these are the examples of scalar quantity. What are the examples of vector quantity? Displacement, we need a direction if we want to displace from one position to another. Velocity, acceleration. So these are the examples of vector quantity, is it? So example of scalar quantity: mass, time, speed, area, volume. Then example of vector quantity: displacement, velocity, acceleration. So this is the very simple concept about scalar quantity and vector quantity. Now next is, that is fundamental unit, derived unit. You know that in our subject, because this mechanics subject is related with the design field. After that mechanics, there is a subject SOM, then TOM, then design of machine element. Okay, that means in every numerical based subject, unit plays a very important role. So then what do you mean by fundamental unit and what do you mean by derived unit? The word itself tell you that what do you mean by fundamental and what do you mean by derived. So fundamental unit are those unit which are not depends on another unit. Then what do you mean by derived unit? Exactly opposite to that. Derived unit are those unit which are depends on another unit. Is it clear? Very simple. Those unit are not depends on another, it is nothing but a fundamental, and those unit which are depends on another, it is nothing but a derived unit. So what are the example of fundamental unit? Is it? So very simple. First one is the length. You can measure that length directly. Is it? Then time. That these are the that means unit of length, unit of time. These are the examples of fundamental unit. Is it? Now what are the examples of derived unit? that is area, the unit of area, meter square, mm square. That means area is equal to length into width. That means that unit of area can be derived from the units of length and width. So unit of area is the derived unit of volume, unit of that is velocity. All these units are the examples of derived unit. Okay, so see, this is a simple basic fundamental of mechanics. Okay, very simple. That is what is mechanics. Then what is the classification of mechanics? Mechanics classified into two terms: statics, dynamics. Dynamics is classified into two terms: kinetics, kinematics. Then what is mass, what is weight. Then next one is the scalar quantity, vector quantity, fundamental unit, derived unit. So this one is the very simple regarding the fundamental of mechanics. Okay, in next lecture we will start the actual concept related with the force. Okay, thank you guys.